Hello everyone, welcome to the Tableau Consultant Certification Question Preparation Series Part 8. Let's move to the questions. A Tableau consultant is designing a dashboard for a client who wants to track the average time to sell products after their release. The data include product release dates and sales dates. Which calculation should the consultant implement to meet this requirement in Tableau? Here correct option is option D, a level of details expression to find the average number of days from release to sales for all products. The level of expression, that is LOD, is appropriate for calculating the average time for release to sales across all products, as it allows for an aggregation measure for while taking into account the granularity of each product's data. So LOD will be the best suit for here. Let's take a look why other options are incorrect. A calculated field calculates only individual products, not the average. So again, this option is not correct. Option B, a fixed calculation to compare the release and sales date for each product. Again, this does not compute the required average length of a time. And this is the running average. This is not a release to sale duration. So this is again not a correct option. So your option D is correct. Moving to the next question. A consultant is tasked with setting up RLS for Tableau report in a large organization where access needs to be based on the departmental roles. The organization has a specific data access requirement for each department. How should the consultant structure RLS? So here correct option is a C, implement group function to manage accesses rights based on the departmental roles within the organization. So as implementing group function to manage access right based on the departmental role within the organization will be the best suitable option here, as implementing group function is the most efficient and scalable approach for managing RLS in the scenario. Group function allows the consultant to assign access right based on the predefined departmental roles, making it easier to manage access for large number of users. So that's why option C is correct. Let's check why other options are incorrect. So individual user functions would be too granular and complex to manage in a large organization with multiple departments. That's why this option is not correct. Creating a single universal access would not meet the specific access requirement for different departments, and manually adjusting access rights for each time is a time consuming and not feasible for dynamic role changes. So option C is correct over here. Moving to the next question. A financial institution using a Tableau needs to ensure that its data handling aligns with industry specific compliance standard, which include strict audit trails and usage monitoring. Which Tableau capability aligns best with this requirement? So here correct option is C, implement Tableau server comprehensive audit usage tracking feature. So this usage tracking feature provides details log on user activity, dashboard access, and data source interaction, fulfilling compliance needs for industries like finance, which require verified audit trails. So that's the option C is correct. Let's check why other options are incorrect. Enable Tableau data source certification to ensure all data source meet compliance standard. So data source certification ensures quality but does not provide audit trails or monitoring. The Tableau's row level security, again, it gives the control on access but does not track audit and user activity logs. And the Tableau data visualization best practice, it's improve the readability but do not address compliances or auditing needs. So that's why option C is the correct here. Implement Tableau server comprehensive audit and usage tracking feature. Moving to the next question. In a Tableau workbook, a consultant use a calculated field to determine whether sales target are met. However, the client wants to apply a date range filter and have this filter impact the target calculation. How can the consultant ensure the date range filter affects the calculated field in line with Tableau order of operations? So here correct option is B. Make the date range filter a context filter to ensure it impacts the calculated field. As Context filter ensure the filter is applied before the calculated field runs. So it will be the first filter in that sheet should be applied. Matching Tableau order of operation where context filters are processed prior to row level calculation. So that's why uh, context filter is the best option here. Let's check why other options are incorrect. So place the data range filter on the filter shape and set it to affect all using related data source. The normal filters do not change evaluation property. So let's say date range filter will not change. Create a parameter for a date range and use it as a calculated field. So parameter do not force filter to apply before calculation execution. So it will be again not a correct option. Use an LOD expression to incorporate the date range directly into calculated fields. LOD controls granularity but do not ensure the filter precedence. So that's why LOD again it's not a correct option. So option B is correct here. Moving to the next question. A Tableau consultant is creating a visualization for a logistic company that wants to understand the flow of goods between multiple warehouse and distribution centers. Which advanced chart type would be the most appropriate for this analysis? So here we want to show the flow, then Sankey diagram will be the best solution. As a flow of goods in across multiple location, Sankey diagram will show the best visuals. And as Sankey diagram will clearly represent both direction and volume of movement, so making it a perfect for logistic flow analysis. Radar chart visualization visualize a comprehensive metric, not a movement or flow. It's something like a KPIs. Tile map work for geographic heat distribution, not flow between nodes. And small multiple KPIs compare many visuals views but do not show directional flow. So that's why Sankey diagram will be the best suitable visualization here. Going to the next question. A Tableau consultant is creating a customized sales performance dashboard. The client wants to see the percentage change in sales compared to the previous month. Which calculation is necessary to implement this requirement in a Tableau? So here correct option is option D. A table calculation using the percent difference option comparing the current month to the previous month. So this option is the most direct and effective way to calculate the percentage change in sales from previous month. This allows for dynamic comparison as the data updates. That's why D option is correct. Let's check why other options are incorrect. So simply using sum of sales does not automatically calculate the percentage change, and the LOD expression are better for fixed level of comparison, not for the dynamic MOM change. And the running total calculation accumulates values over time, not what needed for percentage change. That's why these three options are not correct. Moving to the next question. In the context of translating analytical requirements for a Tableau, how should the data granularity be approached for optimal dashboard performance? Here option B is correct. Choose the level of granularity that balances details with dashboard performance and user needs. So this will offer detail while maintaining the smooth dashboard performance. Too much details will slow the dashboard and too much details reduce the insight, and balance is the key. So balancing in between is the key. So that's why B option is correct. The A option saying the highest level of granularity, it will leads to the performance degradation. So that's why option A is not correct. Limit the data granularity. So it will loses the deep analytical value. It will not give a better insights where if you do not have the lowest granularity. Allow users to set their preferred data granularity dynamically regardless of performance implication. So it will cause unpredictable performance issues. That's why option D is not correct. Moving to the next question. In a considering a migration from an on-premises solution to Tableau Cloud, what should be the primary focus? So here option D is correct. Assessing how data security and compliance requirements are met in the Tableau Cloud environment. So if this is assessing how data security and compliance requirements are met in a Tableau Cloud environment when considering migration from Tableau server or on-premises solution to Tableau Cloud, its primary focus should be on how data security and compliances requirements are met in a cloud environment. This includes understanding Tableau cloud security features, compliance and with relevant data protection regulation, and how it aligns with the organization's data governance policy. That's why option D is correct. Let's check why other options are incorrect. So ensuring that every report has an identical design. So design consistency is important, but it is a secondary to security and compliance consideration. And evaluating the need of physical server. So the need of physical server is typically reduced or eliminated when moving to a cloud-based solution, but this is not a primary focus of the migration decision. Comparing the visual appeal of a dashboard between on-premises solution and Tableau cloud. So visual appeal is important, but it is not critical as ensuring data security and compliance. These options are not correct. Moving to the next question. In a designing a Tableau workbook for analyzing customer feedback scores, the client wants to classify scores into categories: high score above 80, mediums for score between 50 to 80, and low for score below 50. What type of calculation should the consultant use to create these categories in Tableau? So yes, option A is correct. And if then statement to classify score into three categories. This is the best option, as if n statement is the most appropriate calculation for this requirement, as it allow the consultant to directly categorize score based on the specific or specified threshold, like for example greater than 80 to high, 50 to 80 to medium, and below 50 to low, right? So that's why option A is correct. Let's check why B, C, D are incorrect. A basic arithmetic calculation to average the scores and then categorize them. Again, averaging score does not categorize them into the desired group, right? That's why option B is not correct. A percentile calculation to categorize scores based on their distribution. So percentile calculation are used for statistical distribution analysis, and it's not a simple threshold classification. That's why option C is not correct. A window calculation to compare scores across different customer segment. Window calculation compares across partition, not to categorize in individual values. So option D is not correct. Moving to the next or last question of this part. When mapping data products to Tableau capabilities, what aspect should be prioritized to align with business needs? So here option C is correct. Aligning Tableau data visualization and analysis features with the key objective of the data products. So the priority when mapping the data products to Tableau is to align Tableau analysis and visualization capabilities with the core purpose and objective of those data products, ensuring the business decision improve rather than just copying existing formats. So this is the best solution over here. And let's check why other options are incorrect. Ensuring that every existing data product has an exact counterpart in Tableau. Not every legacy data product needs a Tableau duplicate, right? So that's why option A is not correct. Transitioning all data products to Tableau. Some reports may be outdated and unnecessary to migrate, so not needed to transitioning all data products to Tableau. And replicating the exact layout is not a goal. Value delivering insights clarity. So option D is not that much correct. So this will end to this part. Thank you for watching. Subscribe and stay connected. Thank you.